Hi, I just want to show you how you can use the ruler image for which I have a nice little PDF for you to measure the RF of the bands. So I have that ruler image file on my PDF viewer. You probably use Adobe or something like that. And I have my image downloaded to my computer from this assignment, and I'm going to click on the top bar so I could move it, and on my computer that causes this to be a little bit transparent, so that's convenient. Now I measure from the top of the image. You see there at the top of the image it says 0 millimeters, so I'm using this part right here. You see what I'm pointing at? This part right here of the ruler. All right. So I'm going to measure. I'm going to say 0 is the top of my image right there. That's the top of my image, and measure all the way down to the bottom of the image. I see it's 145, maybe 145.1. All right. You see what I did there? I saw that this bottom blue edge, not the band, but the bottom blue edge of my image there is it landed right about here, 145.1. That's millimeters. I'm using millimeters. Now, usually you measure down to the bromophenol blue loading dye line, which would be right here, but some of the images in the Canvas assignment that I have for you don't show the loading dye line, and for that reason I want you all to measure to the bottom of the image. Sorry about that, but the bottom of the image, just like I just did right here, will be fine. Alright, so let me take some notes here. So I've got the bottom is 145.1 millimeters. All right, and now I'm going to measure some of the reference ladder. Now I could see that this is not the reference ladder because these bands are not as evenly spread out as, let's say, these bands are. All right, so these bands came from the experiment. This is the reference ladder. You know, the reference ladder is something you just buy from a chemical company, and it already has everything you need in there. It has the SDS, the Kumasi blue, bromophenol blue, everything is in there. So now I'm going to line this up again with 0 at the top. Now I'm going to measure the first band at the top there. I see the center of the band is on the 20. So I'm going to call that 20.0 millimeters. All right, so go to my notes here. So first band, 20.0 millimeters. All right. So what about the second band? Well, let's see. Get rid of the notes there. All right. So the second band, line this up again. The second band, I'm seeing the second band at 35, 36, 37. The center of the second band is about 37.5 millimeters down. 37.5 millimeters. Okay. So 37.5 millimeters. Third band. Right now, the third band. Now, folks, I'm using the center of the band here. And the reason why I like to use the center is sometimes there's too much protein in there, and I think the center is a good place to stop your measurement, because if there's too much protein, it could be that the stuff at the top of the band is just crowded protein. That's not where it was actually supposed to land. All right, so that's why I like to use the center of the band rather than the top of the band. Okay, now third band looks like it's right on the 50 mark, so I'm going to call that 50.0 millimeters. Now, that's kind of an interesting little thing to think about, though. What about the material at the bottom of a very fat band? What would that be about? Like, how would you get material there? I'm not sure how you would get that, but if you look at the fattest band on the gel here, it has the greatest width at the center. So I think the center is where we should be measuring. So anyways, let me continue measuring the center, measuring to the centers of these bands. Hey, what happened to my ruler? Ah, there it is. Okay, the ruler. All right. So line up the ruler with the top, and the center of the fourth band looks like it's at 61.0. You see that? That's at the 61 mark. Center of the band is at the 61 mark. 61.0. I think it's important. It's probably not actually important to a real biochemistry experiment, because the molecular weight that is determined by gel electrophoresis is just a rough molecular weight. These days, when you want to get the real molecular weight, you throw it into the mass spec, of course, and then they'll give you the actual molecular with very good resolution. But this is just to give us an idea of what the molecular weight is. So I like to use tenths of millimeters, and the reason is these tick marks are, every tick mark is 1 millimeter. So what if the center of a band seems to be in between two tick marks? Should I use the lower mark or the higher mark? I like to guess the next digit after the single millimeter digit. That's what I've been doing. That's why I'm going to the 10th place. I would like it if you did the same thing, but I am not sure that everybody in the biochemistry world does that. It might just be me. But I would like it if you would do the same, if you would. All right, now the next band over is looks like 85, between 85 and 86 millimeters. So it looks like, I'll say 85.5. So the fifth band is 85.5 millimeters. Let's go for the sixth band. Oh, I'm moving the wrong thing. Where's the picture? Oh, here it is. Let's go for the sixth band. Sixth band is at 110, maybe 111. I'm going to call that, I'm going to say it's 111.0. Okay. And seventh band. Yeah, looks like 125, 6, 7, 8, maybe 128.0. And the last band looks like 140, 139, maybe 139.5. All right. So okay, now those are not the RFs. Now to get the RFs, I have to do some division, remember? So I'm going to copy all this and paste it into my spreadsheet program. I don't have Microsoft Excel because I'm not using a product. I mean, my operating system doesn't work with Microsoft Excel. So I'm using LibreOffice Calc. It works just like Microsoft Excel, but it's free. And well, Microsoft Excel for us at East LA College is also free, but you know what I mean, yeah? So I'm going to copy these numbers down: 20, 37.5, 50, 61, 85.5, 111, 128, 139.5, and then I'm going to get the RFs. So the RFs are right here. These RFs are this number divided by the bottom, which is 145.1, 145.1, all right? This is just like what you did with the TLC experiments. Those are all my RFs, okay? And now I'm going to get the molecular weights. So, well, I think you know how to do the log molecular weights, actually, because you did that for the gel filtration chromatography. So you will have some molecular weights. Let's say that the molecular weights, these are given, right? So these are given in the assignment, you'll see. Let's say the molecular weights are like 142, or how about 2? We'll go big here. How about that? 142, 100, 95, 86. I'm just making these up. 77, 55, and 20. Okay, I just totally made those up. So this is your x-axis, and this will be your y-axis. So your y-axis is going to be the log base 10. Log. I think you can just write log, but I'm using log 10 just because I'm not sure if log is the natural log or just the normal log base 10. But anyways, log 10 works on my software. You can figure out what it is on your software. Oops, this is the wrong one. It's this one, right? So log base 10 of that. Okay, and then I'm going to get the skinny plus sign by hovering over this solid black square there, and then that's the log base 10. And then I'm going to graph these. Now, when I graph these, I'm not going to get a really good line the way you're going to get because I totally made up this data. So I'm going to insert the chart. You want the XY scatter. Feel free to stop the video if you know. Hey, I have some nice looking data here. So let's see. Can I get a trend line here? Can I get a trend line? Yeah, insert a trend line. Hey, my r squared is 0.8. Okay, your r squared is going to be 0.9 something. But hey, it's not bad for some wild guesses just to give you an example of how to use the software. Now, I need you to please put a title on this chart, and please label the y-axis so I know that you know what it is. It's the log of the molecular weight. There are no units for log molecular weight. It's just log molecular weight. And then please label the x-axis so I know that you know what it is. It's just RF. There are no units for RF. RF stands for retention factor. Thank you. Bye.